Chapter 6, Electrical Systems, Part 2 of 3. Digital multimeters. A multimeter is a measuring instrument that combines an ammeter to measure current, a voltmeter to measure voltage, and an ohm meter to measure resistance. Some multimeters have more advanced measuring capabilities such as capacitance and frequency. Using a digital multimeter. Step 1. Disconnect the power from the circuit being tested. Step 2. Connect the black test probe to the common terminal. Step 3. If you're using voltage, resistance, or checking for continuity, connect the red test probe to the appropriate place. Or, Step 3, if you're measuring up to 400 milliamps, connect to the appropriate place. Or Step 3, if you're measuring to 10 amps, connect to the appropriate place. Measuring voltage. Step 1. Before taking a voltage measurement using your multimeter, you must know whether the voltage is alternating current or direct current. If you're measuring a battery, the voltage is direct current. If you're measuring an outlet from your home, the voltage is alternating current. Step 2. When measuring the voltage across an electrical component within a circuit, place the multimeter in parallel with the electrical component. Measuring resistance. Step 1. Resistance is always measured when the power is disconnected. Step 2. Isolate the component or components to be measured and then select the proper resistance setting on the multimeter. Step 3. Touch the probes to both sides of the component to take the reading from the digital display. Measuring current. Step 1. Before measuring the current in a circuit, disconnect the power of the circuit. Step 2. Place the multimeter in series with the circuit or components. Be sure to connect the red probe to the proper terminal on the multimeter. Step 3. Select the highest current setting on the multimeter. Step 4. Turn the power back on the circuit. Some metric prefixes. Pico, the symbol is P. There's the number that it's associated with, or 1.0 times 10 to the negative 12th. This means that it's 1/1 millionth of a unit. Common electrical abbreviations, a picoampere, which looks just like that. Nano, letters N, 1.0 times 10 to the negative 9th, 1,000th of 1/1 millionth of a unit, nanoampere. Micro, which is 1.0 times 10 to the negative 6th, which is 1 millionth of 1 unit, like a microampere. Milli, which is 1/1000th of a unit, like a millivolt. Kilo, 1,000 of 1 unit, like kilovolts. And mega, 1 million of 1 unit, like mega ohms. Common electrical components, resistors. As its name implies, a resistor is a simple electronic component that provides resistance to flow of electricity. Resistor color code. Instead of printing the actual ohm value on a resistor, the Electronics Industries Association, or EIA, established a color coding system to identify the value of a through-hole style fixed resistor. The color code consists of 3 or 4 bands of color wrapped around cylindrically shaped resistors. 4-band color codes use the first 2 bands to indicate the significant figures of resistance value, the third band as the multiplier, and the last band to indicate the tolerance of the resistor. The tolerance is the amount of deviation the value may vary from the actual resistance. Resistors with only 3 bands have no tolerance band. The tolerance is assumed to be plus or minus 20%. Tolerance bands. The 4th band on a 4-band resistor and the 5th band on a 5-band resistor are the tolerance bands. Gold and silver are commonly used for the tolerance band. Gold indicates a tolerance of plus or minus 5%. Silver indicates tolerance of plus or minus 10%. Gold and silver colors as multipliers. For resistors with values lower than 10 ohms, a special multiplier value is used on the 3rd band. When gold is present in the 3rd band, the first two digits are multiplied by 0.1. When silver is present in the third band, the first two digits are multiplied by 0.01. The resistor color code chart. Go ahead and pause the video at this point and copy this chart into your engineering notebook. Electrical circuits, basic circuits. An electrical circuit is a closed path through which electricity can flow between some terminals of power source and through one or more electrical components. Some electrical components are used to control the flow of electricity. Other components are used to convert electrical energy into some other form of energy for the purpose of performing a task. Wires or metal traces provide the pathway through which electricity will flow. A load device, such as a buzzer or lamp, is used to transform electrical energy into another form of energy. When current is able to flow through a circuit, it is said to be closed. A closed circuit provides a path for electrical flow if voltage is applied to it. If the circuit has a break in it and does not allow the flow of electricity through it, it is called an open circuit. Electrical circuits, Ohm's law. Ohm's law states that the direct current in a conductor is directly proportional to the voltage applied across the conductor and inversely proportional to the conductor's resistance. We use the formula current, or I, equals voltage, V, divided by the resistance, R. And then here you can see the symbol, the unit of measurement, and the unit abbreviation. And then this is a little tool here. The idea is if you're trying to find voltage, you cover up voltage with your finger, and then you multiply the current and the resistance, and that gives you voltage. So it's a way of rearranging the formula to find whatever you're looking for. Series circuits. A series circuit provides only one path of electricity to flow through two or more electrical components. Resistance in series circuits. Currents must pass through all of the resistors in a series circuit because there is only one path for each current. Each additional resistor placed in a series circuit adds more opposition to the current. The total resistance of a series circuit is equal to the sum of all the resistors in the circuit. So here we can see the resistance total is equal to the resistance of series circuit 1, the resistance of 2, all the way up to however many you have. Current in series circuits. Current in a series circuit means the same no matter where you take the reading. Voltage and current are directly proportional given a constant resistance. Voltage in series circuit. Voltage does not remain constant throughout a series circuit. Kirchhoff's voltage law states that the sum of the individual voltage drops in a single loop and the applied voltage must equal 0. So all of the voltages have to equal 0. Voltage divider rule. Because the same current passes through every component in a series circuit, the voltage drop of each component is equal to the same percentage of the circuit's applied voltage as the resistor is of the total resistance. The voltage divider rule can be used to calculate the voltage drop of any resistor in a series circuit. If you know the applied voltage, the individual resistor values, and the total resistance, you have enough information to solve for each of the following voltage drops. The equation is Vx equals Rx divided by RT times V total. Vx is the voltage drop across the selected resistor, Vt is the applied voltage to the circuit, Rx is the resistance value of the selected resistor, and RT is the total resistance of the circuit. Practice problem using the voltage divider rule. So you have your equation and you have your information here. Go ahead and try to figure out the missing component. That ends part 2.